Hello Joe, welcome to another GameMaker tutorial. In today's video, we are going to be going over how to do point data and anchor points in GameMaker. So what exactly does that mean? Well, anchor points are a way of defining a fixed position relative to a certain object so that you can have another object follow along in a consistent, determined manner. So if you take a look at this example we have on screen, you can see that when our player throws the axe at this enemy, the axe object sticks to the enemy and tracks with them. In this example, it's very simple and it doesn't look that complicated, but in the system that we're going to be setting up, we can define a very complex set of rules that will allow us to draw our object in any sort of angle, depth, position. Those properties will be fixed to specific sprites and specific frames of each object. So in this example, it's very simple because the axe just sticks to the graver and moves. But in other examples in this game, when the enemy goes flying backwards and kind of gets rotated back, the axe rotates with them and sticks to their chest. So you get a consistent, nice animation and it looks realistic, but we're doing all of this with code. So the benefit to this is that you don't have to animate all of these different scenarios or possibilities separately. You create one dynamic system through code that can be used for any object in the rest of the game. I'm going to go ahead and show another example. If we take a look at this video here from a platformer that I was working on, I have a character that has a gun and we want the bullets to come out always from the tip of this gun. So how would we do that? Especially because this character has like 20 different animations. The gun is at different positions in each animation. So how do we define where those bullets get created from? Well, we would put an anchor point at the end of the gun. And then what we can do is we can always spawn those bullets from that anchor point, no matter where it is. And as long as the anchor point is defined properly, then the bullet will always know where to be created. And so what we do is we define an XY, angle, depth, direction, whatever, for every frame of the object. And then we can spawn or place or stick or do any sort of object manipulation that we want to, because all of this data is predefined, and then we get to do whatever we want with it. So I know that might be a little confusing and it might be a little hard to understand, but just imagine any time that you want one object to stick to another object in a very specific position, angle, depth, then you're going to want to use anchor points. And especially if this position or this anchor point is different for each frame of the sprite, then that's where we really get a lot of our benefits. So last thing I want to show you before we get started is I'm going to show you a screenshot of what the code is going to look like. And so here is how we have this set up in Totem, that first example I showed you. On the right side, we have all of our anchor point data defined for each frame of each object. And then on the left, all we do is we have one very concise script that does all of the manipulations to that axe object. So in this situation, we're using an axe object and that axe sticks to these data points. But using the same implementation, we could have any object stick to that enemy. We could have arrows. We could do, if we wanted to implement a bow and arrow system, we could have the arrows, once they hit the enemy, would stick and they would rotate and follow and track that object. We could have the axe object. We could do swords. You stick a sword into the enemy and when the enemy dies or moves around, the sword stays stuck in that enemy and it moves and tracks and does everything dynamically. So when we look at this on the right side, it might look a little overwhelming and it is a bit tedious of a process to do, to have to go through and put all of this data and match it up for each frame. And it's not a fun process to do, but the benefits of it are so significant because now we have one universal system and one universal solution that is so dynamic and robust that we can implement pretty much anything we want with it moving forward. And it's one of those things, you define it once and then you forget about it and you're done with it for the rest of the game. Okay, so without saying anything else, I'm going to pull up the project that we're going to be working in. And this is an example project that I've just been working on. The project itself is not really important, but this is just a good example for us to showcase how we're going to implement this. So if we go ahead and take a look at our project here, you'll notice that our player can move around and we can pick up these little turnip objects. Now, right now, the turnip just sits in front of the player and it's not very exciting. It doesn't really look that great. It's kind of flat. We can use anchor points to make this look way more dynamic, way more interesting, and we can then open up the door to a ton of future functionality if we want to add to it later. So let's go ahead and get started, and we're going to implement anchor point data to this turnip so that it sticks to this player's hand as the player moves around. First thing we want to do is I'm going to go ahead and create a script, and I'm going to create a script called global point data. We'll say anchor point data. In my game controller, this is just where I'm going to instantiate the code, but you can call this anywhere in your game that you would like. Ideally, it's going to be somewhere at the beginning so that this gets set up right at the beginning of the game, and then all your objects and scripts and everything have access to it later on in the rest of the game. So I'm going to say global anchor point data. All right, and this gets called at the very beginning of the game in the create event. Okay, so now how do we do this? Well, we're going to create a global variable. We're going to say global anchor data. Is normally if I wanted to define this as some sort of array, right? Normally anchor data, I would, throw some values in here. Maybe this is my X and this is my Y position, right? And this could be, 100 and this could be 234, okay? But this is pretty much a very hard defined value, and there's no association with these numbers to our objects and to our sprites. So how do we make that association between our anchor point data and the object, and then also put it with the correct sprite and then the correct frame? Now, normally if you were to try to hard code this, you could say if object index equals obj enemy and obj enemy dot sprite index equals, SPR enemy idle and the frame equals frame 3, then this is what the sprite, what the anchor data is going to be. But that is just a very tedious and kind of sloppy way to do this. So how can we make this more robust? Well, what we can do is we can use our object indexes and our sprite indices to create our array. So what I could say here is, since we are going to be working with our player, right? We want the turnip to stick to the player. Our player is going to have the anchor points. So how can we do this? We can say obj player, and we're going to say SPR player idle. And so now what we've done is we've used our object index and our sprite index to create an array. And this is a global variable called anchor data. So if I go ahead and duplicate this line, I could do the same thing for each of the sprites. So I could say player run. I could say player jump. I could say player fall. I can do this for each of them. And right away, what we're doing is we're already parsing out our data in a nice way to be associated with both the object index and the sprite index. Okay, so now what do we do? Well, we've just created these empty arrays. We can't really do a whole lot with them. Well, what we're going to do is we're going to create a series of properties that we're also going to put inside of another array. And then these indices in this array are going to associate to the current frame of that animation. So let me explain what that means. So if I open up my player sprite and I go to player idle, you can see that we have 4 frames, okay? So this means that under our obj player, SPR player idle, we want 4 pieces of data. And each one of these lines inserts is going to associate with a frame. Okay, so if we were to open up our player run object or sprite, you would see that we also have 4 frames. How about one that has a different frame? Jump only has 1 frame. So if we come up here to our obj player, SPR player jump, we're only going to have 1 piece of data there. So hopefully this makes sense. We are just basically creating 1 row of data per frame of our object. So let's go ahead and fill these out. We said our player, or our run sprite had 4 frames, and our fall has 1 frame as well. So theoretically, you would want to do these for each of your sprites, but we're just going to do it for these 4 sprites just for the sake of saving time on this video. Okay, so now what we've done is we've set up the structure of our data, but now what do we plug in here into these arrays? Well, theoretically, you could put whatever you wanted to here. This is totally up to you to put as much information as you want. For the sake of this video and just for an example, I'm only going to put 4 pieces of data here. I'm going to say an X, a Y, a direction, and a depth value. And this is going to be the case for each of these. Okay, so each of these are going to hold 4 pieces of data: an X, a Y, a direction, and a depth. So let's go ahead and open up our idle sprite. And we know that our origin is here at the bottom center at 2855. So when the player is holding the turnip, where do we want to set up the anchor point? Well, the anchor point would be on the player's hand, right? That would make sense. And let's choose this backhand over here. So we know that the turnip needs to be positioned to this backhand. Well, what is the X and Y position of this backhand relative to the player? Well, if the player's origin is 2855, and let's just pick a point here. Let's just say that this is now going to be our new position, 4843. We just do some basic math and find the distance between the origin and 4843. We know that our origin is at 28, so we can say our X is going to be 28 plus some value equals 48. So what is 28 plus what is going to be equal to 48? So that's going to be 20. So that means we know that we are going to be moving our turnip 20 pixels to the right of our origin to get to this position. And we can do the same thing for Y. So what's our Y origin is 55. So we're going to say 55 plus minus Y equals, and if we start at 55, but we want to anchor it here, we know that Y is now 44. We can see that here. So we know that the distance to go from 55 to 44 is -11. Okay, so here's what we've done. We've said we are going to set our anchor point to be 20 to the right, -11 up, relative to the player object's origin, okay? So now we need to just do that for every frame. Well, in these first 2 frames, the hand doesn't move, so we can just copy this. And for this last frame, it looks like we move down by 4 pixels. So we're going to copy this, and we're going to, instead of moving -11, we're only going to move -7. So I know here I said that we're going to do X, Y, dir, and depth. We're going to do the direction and the depth later, but for right now, let's just do X and Y. Okay, so hopefully this makes sense. Like I said, these coordinates are relative to the player's origin, and this is going to define the first anchor point on the OBJ player, on the sprite player idle, and each of these inserts corresponds to a different frame of that object. Okay, let's go ahead and implement this simplified version of this, and then once this is working, we will add direction, we will add depth, and then we will fill out all of these other sprites as well. So I'm going to go ahead and close all my windows. I'm going to go ahead and open up my OBJ turnip. And my turnip doesn't really have any sort of state machine, but right here you can see that we are checking to see if the turnip is being held, and then we are setting some positions and some values based off of the owner's position and values. So instead of hard defining the position of the turnip relative to the owner, the way that we've been doing it already, instead we want to pull our information from our global anchor data script, and then we want to use that data to then tell the turnip object where it should set its position. So I'm going to go ahead and create a new variable, and I'm going to say var points equals global dot. So here we need to specify what is our object index and what is our sprite index, because keep in mind we are using the object index and the sprite index to define where these data points are stuck in. So what I need to say is I'm going to say owner dot object index, and in this situation the owner of the turnip will always be the player. So getting owner dot object index is the same thing as saying obj player, but this is just a bit more of a dynamic solution. And what we want to do is now we need to specify the sprite index. So we're going to say the same thing. We're going to say owner dot sprite index. And so now what this will do is this will look at the turnip's owner. It will get the object index, which will be obj player, and then it will get the owner's sprite index, which in this case will be SBR player idle, and it will pull that data and store it into a new variable called points. So now what we've done is we've returned this array in a variable called points. So what we can do is now we can go var point, and this is going to be equal to points And remember that this array is set up so that each insert is associated to the frame. I know I've said that 100 times, but it is very important that we keep that in mind. So how do I access that index then if it's based off of the current frame? Well, what we can say is we can say owner.image_index. And what this will do is this will return the current image index of the owner object, which is our obj player. So this will give us, in this situation, 0, 1, 2, or 3, based off of which frame we are currently in. So now we have returned one of these rows as a variable into our point. So now we can start to parse that data out. We can say x is equal to point at the 0 index, and y is equal to point at the 1 index. And again, this is because this is the 0 index. Here's the 1 index, and that's our x value. That's our y value that we're storing there. So now when we go ahead and hard define, when we stick turnip to player, instead of using these kind of hard set values, what we're going to say is we're going to say y is equal to owner.y plus our y value that we just pulled from our data. And in this situation, for our x, we're going to say x is equal to owner.x plus x times the sign of our image x scale. If we go ahead and run this project, what we should see is that the turnip, once we pick it up, you'll notice that the turnip is moving up and down now and matching our idle position, okay? It is pulling from our anchor data, and we defined that those two different frames have different x and y positions, and the turnip pulling that data to determine where itself the turnip will exist. Okay, so now if I try to run though, we're gonna get a crash because we haven't defined the anchor data for any of the other sprites. So it's trying to access the anchor data for the run sprite, but we haven't defined that. So we need to come in here and we need to define the rest of this data. Okay, so now we have successfully defined all of our x and y coordinates. So now, normally you would say, okay, well now we gotta go implement these values into our script. But that's the thing, we don't have to do anything different because the solution for how we pull this data and plug it into our objects and use it is the same. So once you set up the system as we have here, all you have to do is just add your points and everything works automatically and it runs for you. So I don't have to do anything else other than hit play, and this should work with no problem. So if I go ahead and open this up here, I pick up my turnip, and now I can run and the turnip moves with me. And that's really awesome. Like, that's the coolest part of this whole implementation, is that we don't have to add any extra code once we add these new anchor points. The anchor points just take care of themselves. So I'm gonna go ahead and leave that as it is. I'm gonna quickly grab the values for these other two sprites, and then we're gonna move on to implementing depth and direction. Okay, so I quickly added the X and Y positions for our other two sprites, and now we're going to implement direction and depth. So what does this mean, direction and depth? Well, direction is just the direction that we want to draw the sprite on each of these frames. So if we open up our idle sprite again, and we take a look here, well, there's nothing really going on with our angle. Like, the player stays still up and down, and there's no like rotation of the hands or anything. So we're gonna just draw our turnip at a 0 rotation. So I'm gonna go ahead and plug this in. I'm gonna say 0, 0, 0, and 0. And then, so what about our depth? Well, our depth is how we want to draw our depth of the object relative to the parent object, which in this case is the player. For this example, on this sprite, again, on the idle, we're going to say the depth is just the same as the player. We actually want to draw the turnip in front of the player. So that way, you know, if the turnip's behind, it'll look like the hand is kind of on it. So we want to make it look like the hand is kind of behind the turnip holding it. So let's go ahead and just say that our depth is also going to be -1. And this is going to draw the turnip in front of the player. So for this sprite, nothing crazy is going on, right? And then the same for the running sprite. There's really no depth and there's really no angle changes happening here. So I'm going to go ahead and plug in these same values for this sprite as well. If you take a look at jump, you'll notice that there's something totally different about this, in that we can't see this player's backhand where we are going to anchor the turnip to. So what we want to do for this is we want to push the turnip to behind the player so that it looks natural. So if we go to our anchor data and we go to our player jump, we have to plug in some sort of deer here, but we don't know what that is. But we know our depth is going to be +1 relative to the player because we want the turnip to be drawn behind the player instead of in front of the player. So we're going to set a depth value of 1 here. And if we lastly take a look at fall, we will do a depth of -1. So now what do we do for our direction value on these last ones? Well, if you take a look at our jump one, it kind of looks like his hand is back kind of at an angle. So theoretically, if he was holding the turnip straight and he kind of put his hand back, the turnip would rotate with him. So we don't want to draw our rotation at 0. We want to draw a more natural rotation, maybe at like 30 degrees this direction. So let's go ahead and set our direction to be 30. And if we lastly take a look at our fall sprite, you know, his hand is kind of down, but he's kind of moving. So let's go ahead and, we're going to want this to be about 30 degrees, sorry. And the other one is going to be 120 because it's going to be 90. We want it to kind of face this way. So it's going to be 90 plus 30 is 120. And then here we want it to kind of face this way. So it's going to be 30 degrees. Okay, so now we have plugged in and defined the rest of our data. We need to update our implementation because we've now added a new property to the anchor point. So if we go ahead and open up the obj turnip step, we need to define a couple of things. We need to say var deer equals point data at index 2 and var depth equals point data at index 3. So now what do we do with this? Well, now we just plug this new data into our object. So here you can see we're defining the depth. Instead of just saying owner depth -1, we're going to say owner depth plus our depth variable. And in this current implementation, we don't have anything that's determining the image angle. So we would just say image angle equals deer. So now let's go ahead and run it. And you should see a couple things. All right, so when I run, nothing crazy, this looks fine. But when I jump, the turnip goes behind the player. And when I fall, the turnip is in front of the player. Now it looks like our image angle isn't getting set properly. And that's mostly because this is a physics object. So there's some weird stuff going on. So I'm gonna go ahead and set this physics rotation to deer. And if we run it again, this should hopefully solve that problem. Yeah, so here you can see that the turnip is reacting. Now this is a special case because this turnip is a physics object. So for most objects, you won't have to do anything like that. All right, so that's pretty much it for this implementation. I'll go ahead and take a look at our totem code again, and you'll notice that here what we do is we pull our data from this point, and then we apply some sort of random X and Y offset. So for the initial example I showed you of totem where the axe was sticking in the enemy, we wanted some variety so that if multiple axes stuck the enemy, they wouldn't all stick in the same point. So what they do is they pull that point data and then we apply like a random X, just like a slight random X position and a slight random Y position. So it always sticks to that initial point and then we kind of move it just a little bit so that there is some variety there. So depending on how you implement this solution, you are probably going to have to make some slight adjustments and some modifications, but you'll notice that everything else is the same. This is literally the only code that is used to stick that object to that anchor point, and this is the only code that is used to define the anchor point. Now I do want to point out one downside to performance to this solution. So if you're just looking for the general overview of how to do this, you can probably end the video here. But I do want to point out that there is one downside to this implementation. When we define an array, so if I say my array equals empty array, here we are just defining an empty array. And normally if I were to say like, put in some values, then here we have an array of length 4. But if instead I were to say something like this, and I were to define our array the way that we've defined it, then normally we would put something like this. We would say this is 0, 0, this is 0, 1, this is 1, 0, and this is 1, 1. This is just kind of pseudocode. Don't pay too much attention to the syntax, but the point is that if we wanted to define some sort of array, we would start our index of the array at 0, and then we would increment up 1 at a time. The problem is if at any point, if I were to say array 23, 13, or 12, and this were the only implementation, and I were to say, hey, just insert one piece of data here, you know, whatever, obj player, our array, we would look at this and we would think, okay, our array is only of size 1 because we only have one piece of data in it, and there's only one row in the entire array. However, by defining it with this 2312 at the beginning of it, what GameMaker does is it creates an array of 23 length or whatever it is that's empty, and then it puts obj player or whatever our piece of data is at the very bottom. So if I said, you know, my array 13 equals this line here, then this would create 13 rows of empty data before putting our obj player. So now we have a really, really long array that has a bunch of empty values just to hold one insert of data. Now this is what's happening when we do these here. Keep in mind that obj player and SPR player idle are object indexes and sprite indices alike. Okay, so they hold some sort of value. So if we were to take a look at player sprite idle, this would be index of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this has a sprite index of 13. So this is essentially the same thing as saying, okay, this is the 13 value, and obj player has an object index of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this has the same, this is the same thing as saying 20, 13. All right, if we, this is exactly the same thing as saying that. We could say 2014, 2015, and 2016, because these are all linearly set up in our resource tree. So when they get assigned an index, it just starts at the top and goes all the way down. So we could run this code right now and it would run exactly the same. So as I mentioned before, we are defining an array that starts at index 20. So that means we have 19 slots of empty data that are getting created before we insert one row of data. This is not necessarily the most performant solution because we are allocating a bunch of memory and then doing nothing with it for the array. So if you want it to be more optimized, then you could do a couple different solutions. Number one, you can move all of your sprites that are going to be used for this to the top of the resource tree. So if I took all of these sprites and I put these first, then we've immediately solved our sprite problem. And I could do the same thing with the objects. I could put the objects first, therefore their sprite and object indexes would start at 0 and increment upwards, and that would be totally fine. We wouldn't be allocating any extra memory. Another solution was presented by one of my followers on Twitch and in our Discord. We were talking about it. Gleb mentioned he likes to organize his data into a grid and then pull the data based off of that. So you could set up some sort of grid, insert this data in there based off of the sprite index and the object index of the grid, and do some sort of weird manipulation like that. That is also a potentially acceptable solution. However, when you start to implement solutions like that, you start to make this chunk of code a little more complex so that you can't just pull it based off the object index and the sprite index and the image index in this nice kind of dynamic solution that we've created. So I leave this problem up to you guys. Try to play around with it, see if you can come up with a better solution. I have a couple ideas of how I could also implement this. I'd probably maybe use a DS map and then take the object index, sprite index, and image index and convert those into a string and then use that as the key for the DS map and then insert our values into that map using those strings as the identifiers. And then the way DS maps handle the string, the key value pairing, it's more of an optimized memory system. There's a ton of different ways that you guys could go about this. But if you guys find a solution, let me know, leave a comment down below and let me know how it is that you found a way to optimize it. or just let me know how it is that you implemented this solution in general into your project. I'd be interested to hear about it. There are infinite number of things that you could do with this, and there's so many different possibilities that you could use this anchor point system for. You could do dynamic different weapons, kind of like in Enter the Gungeon, where the gun is always sticking to their side. They probably use anchor points. You could use this in any sort of project. So let me know if you guys have any questions. I know it was a little confusing and a little fast, and contextually it might be a little kind of confusing. If you have any questions, feel free to join Discord and shoot me a message directly. The link is down in the description below. I'm streaming a ton on Twitch right now, guys. I know that's why I haven't been uploading a whole lot of videos. It's just because Totem has been going into full swing, and we've been working really hard on that. And I do a lot of live stream dev on Twitch. So if you're interested in following and engaging in conversation, we talk about a lot of dumb things and have a lot of fun over there on Twitch. I'll leave a link down for that below as well. Thank you guys so much. I'll try to upload some more videos. No promises yet, but if you keep pressuring me the way that Gleb has been guilting me into making this video, maybe I'll make some more, guys. Thank you so much. I appreciate you, and I will see you in the next video.